We talked about z-scores in the last two videos as one measure of relative position. So now we're going to talk about percentiles. So the kth percentile, which we denote with a capital P with a little subscript K, of a set of data is a value so that K% of the observations are less than or equal to that value. So what does that mean? Well, a lot of you are parents. For those of you who aren't, your parents would have gotten these results from like standardized testing in elementary school all the way through high school, where when you get your results back, it says little Johnny was in the 95th percentile for students his age. What that means is that 95% of students scored his score or less. So one thing we need to remember when we talked about the median? The median divides the lower 50% of the data from the upper 50% of the data, which makes it a special case of the percentile. So the median is the same thing as P50 or the 50th percentile. So the word percentile comes from the words per and cent. So percentile, per means divide, and cent comes from Latin for 100. You can remember that by there are 100 cents or pennies in a dollar. So percentile divides a group of data, if we write the data in ascending order, into 100 parts. So we can determine only 99 percentiles. So that's P1, 2, 3, 4, all the way up to P99. The largest data value would be P100, but we don't talk about it that way. So if you look, your smallest data value is on the left, and then we put the percentile so that we get 1% in every little division. So P1 would be the bottom 1%, and P2 would be the bottom 2%. When we get to the bigger numbers, so like P99, we don't call that anymore the bottom 99%. We call it the top 1%. And then P98 is the top 2%, etc. And then, of course, the largest data value is furthest to the right. So Jennifer received the result of her SAT exam. Her mathematics score of 600 was in the 74th percentile. What does that mean? Well, it means that 74% of the scores on the SAT math portion were the same or less than Jennifer's score. So if we had to draw that, here's P74, which is what Jennifer scored. And that means that this blue shady part is 74% of the data. So 74% is of the scores were at or below Jennifer's. That also means that 100 minus 74%, or 26%, 26% of the scores were higher than Jennifer's. So that is the pink part. Okay, let's talk briefly about quartiles. So the most common percentiles are actually quartiles. And if you think about a quarter in relation to a dollar, there's 4 of them. So quartiles divide data sets into 4 equal parts. So the thing that's important to remember here is that the first quartile is the same thing as the 25th percentile. The second quartile is the same as the median, which we've already said is the same as the 50th percentile. And the third quartile is the same as the 75th percentile. So Q1 separates the bottom 25% from the top 75%. It's right here, so you can see there's 25% to the left of it, and if we add the rest up to the right of it, we get 75. Q2, which is the median, separates the bottom 50 from the top 50. And Q3, you can see there's 3 25% to the left, so 75% total to the left, and 25% of the data is to the right. So how do we actually find the quartiles? Well, we can use OneVer Stats in the calculator, or we can use StatCrunch. And so I've got the calculator pulled up now. We are going to enter the numbers into our list. So remember, we go to Stat, and we want Edit, number 1 edit. So we just hit Enter. Now remember, we probably want to clear our list. So highlight the L1 using the arrow keys, hit Clear and Enter. And now we can type in our data. So 189, enter. 1185, enter. 3461, enter. 2336, enter. 21147, enter. 4668, enter. So I'm doing my quick proofread just to make sure. Okay, that looks good. So second mode, remember to quit. Then we're going to go stat over to calc, and we want one var stats. We put our data in list 1. Frequency list should be blank. So we'll go to calculate. Remember, X bar is the mean. SX, the fourth line down, is the sample standard deviation. The sigma X right underneath it is the population standard deviation. N is the number of data points we have, which was 6. And we have that arrow right there, which means scroll down using the arrow key. So here we have the minimum and the maximum we've already talked about, but it also gave us Q1, the median, which we've already talked about, but now we know that's the same as Q2, and the Q3. So we can just go over and record those on our paper. So Q1 is 1185. Q2 is 2898.5. And Q3 is 4668. So if we were going to interpret that first quartile, and since we're talking about vehicle collision claims here, we would say 25% of vehicle collision claims are less than or equal to $1,185, and 75% of vehicle collision claims are more than $1,185. So we'll end this video here, and we'll talk next time about the interquartile range.